Okay, we're recording it. So, yep, we're just moving out of the theoretical topics on DevOps and microservices. Go through and let me know if something needs to be explained. We're going to start directly with Docker here. Okay, I hope this is fine with everyone. So, before we start with Docker, let's talk about virtualization. I'm pretty sure everyone in Dell is aware of this. Now, virtualization, we're going to talk about the need for virtualization and why it is required, what is its implementations, and the different techniques that virtualization implies to address the issues the industry had. Let's say the traditional architecture, when we used to have a single server.
Uh, Sorry, Deepak. Can you talk? It's very slow, your voice.
Is it for you only or is it for everyone?
If you will
No,
speak little
your voice.
loud, that will be helpful.
Okay. How about now? Is the voice fine? Hello.
but not clear for Deepak.
Mm, I'm speaking in my loudest voice. Let me just change the position of my system a bit closer. How about now? Is it fine?
Yeah, Deepak. Yeah, it is clear.
Okay, cool. So yes, this is the traditional architecture, how the system used to look like. We used to have a virtual machine. On top of this virtual machine, we used to have our operating systems running. And on top of this operating system, we used to deploy our application. Now, the challenge here is this server. Let's say the server is a 32 gig server with 4 core or 8 cores server. Now, if our application is just using 2 cores and just 10 or 12 gigs, we're just wasting the other cores and the RAM, right? It's kind of waste of the hardware and the power as well. So what people thought, okay, why can't we have something, some kind of architecture where we just spin up servers at our desired capacity, and whatever is left over, we can reuse it for some other applications. So that was the need for virtualization, and then virtualization came into picture where now we have a server on top of which we have an operating system or we don't have an operating system. Both cases are valid. And on top of that server or the operating system, we have a layer called as virtualization layer. Now this virtualization layer allowed us to spin up multiple virtual machines on top of the same server, depending upon our application capacity. So the problem was solved. Now we can spin up our virtual machines as per the requirement of the applications and deploy it. And now wastage of resources has been eliminated. Let's talk about a few more challenges which prompted the use of virtual machines. Like our applications, not all applications run on the same platform, right? Some applications need Windows platform, some needs Linux. So there are different operating systems, the different versions of operating systems are required by the applications. So the same operating system and the server cannot be used to host multiple applications, right? So to isolate that environment, we use this virtualization layer, and now we have different OS for different operating systems and different versions. Now these applications could also have dependencies on external libraries. Let's say someone says, let's deploy all the applications on top of this server. But the challenge is 2 or more different applications can have different set of dependencies, right? And those dependencies can um, impact each other, right? So that was another reason why virtualization came into picture, to get resolved the application dependencies and their external libraries. Now, next we're going to talk about the virtual machines, hypervisor, host OS, and guest operating system. So we have a server. This is the bare metal or the physical server, on top of which the operating system that we install is called as host operating system. Now, on top of this host operating system, the virtualization software that we install, or the software which allows us to create multiple virtual machines, is called as hypervisor. Now, this on top of this hypervisor, our virtual machines are running. So this is the virtual machine layer. Okay. And now these virtual machines have an operating system which is termed as guest operating system or guest OS. Now every guest OS will have their own binary and library folders, etc. And all these operating systems are isolated with each other, and different applications are deployed, like app 1, app 2, and app 3 are deployed on top of this virtual machine. Okay, so now we know what is a physical server, what is a host OS, what is a hypervisor, and what is a guest OS, how the structure of virtual machine looks like. So these virtual machines, when we talk about these, are something not very new. Even during 1960s, they were heavily used for multitasking of the programs, where every program used to have full access to the machine. It used to appear as if every program is having full access to the server hardware. And in this virtualization domain, VMware has been a significant player. They have been performing, doing a lot of virtualization techniques, bringing out to us, and we have been using it ever since. So this virtualization software that we use to create virtual machines is termed as hypervisor. And what does this hypervisor tend to do? This hypervisor tends to provide the guest operating system, that is the virtual machine operating system, with some access to the hardware. So the guest operating system or the virtual machine operating system thinks as if it is actually communicating to a hardware, but in reality it is an emulated hardware. Okay. Now these hypervisors are again classified into two types, that is type 1 and type 2. The type 1 hypervisors are more close to the hardware, where you have a hardware and on top of which we have the hypervisor deployed, and on top of this hypervisor the virtual machines are running, like operating system on OS2, and on top of which the applications are running. Now, anyone who can help me up understand where do we find a use case for type 1 hypervisors? Hello? Guys, am I audible?
Yes, Deepak.
Yes, Deepak.
Yes, so my question to everyone is, where do you think the type 1 hypervisor would be much used for? Okay, let's see. These type 1 hypervisor are also native or bare metal hypervisors, means they're directly running on top of the hardware. Definitely there's some modifications on the Linux kernel. Now, on top of this hypervisor, the guest operating system's running as a process on the host. Now, since there is no operating system layer between the hardware and the OS, it's just the hypervisor and some modified Linux kernel. That means it's very much performance intensive. So it can be used on very high-end servers, and examples of such hypervisors are Oracle VM servers, Citrix Zen server, VMware ESX or ESXi, Microsoft Hyper-V. I've not used Hyper-V, but yes, it's also part of the type 1. So these high-end servers means the cloud servers that we use, like Amazon Web Services, DigitalOcean, Azure, Google Cloud, Compute Cloud, all these things, they all rely on the type 1 hypervisors. Are we clear on that part?
Deepak, can you explain again? So the type 1. So on top of the server, so we have the hypervisor. So on the top of a hypervisor, that is the base OS, then OS, correct?
On top of the hypervisor, you are running your virtual machines. Virtual machine 1, OS 1, virtual machine 2 with OS 2.
So in the hypervisor, suppose in the hypervisor Oracle VM, that is Oracle, you can take the hypervisor. In that particular Oracle, so you need to select any OS, like any OS package, means either Windows, either Linux, anything. Correct?
Right. You have to select the OS image and you're good to go. Okay.
Okay. Means what is the difference? So as you mentioned, type 1, that is the a native of bare metal hypervisor. What is the meaning that also not clear for me?
We have not yet talked about type 2. Okay. Let's see the type 2. So the type 2 are also referred as hosted hypervisor. So the benefits of type 2 is that you have your hardware, let's say our laptop, on top of which we have our operating system, let's say Windows. On top of this operating system, we install the hypervisor, let's say VirtualBox. Okay, and now on top of this VirtualBox or the hypervisor, we are running operating system. The one we did, CubeM, Cube, Worker 1, Worker 2, right? So this is the type 2 hypervisor, which is also referred as hosted hypervisor. This is actually running as a process on any conventional OS, and this where the guest operating system calls are mapped to the OS system calls by the hypervisor. So where is this used for? It's used for tech enthusiasts, people like me and you, who use this technology on their desktop or laptops and see how things work in virtualization, like VMware Player, VMware Workstation, or Oracle VirtualBox. Okay, does this helps you now? Hello.
Yes, yes, Deep. Yeah.
So in the type 1, there's no operating system involved, because you see, even if you have a single operating system, you have to give a 2 gigs of RAM and 1 or 2 cores to the operating system itself. That's the bare minimum you can give. Now think about AWS, who have thousands and thousands of servers. Let's say even thousands of servers. That means for each server, you are providing them 2 gigs of RAM. That means you're already providing 2 terabytes of RAM just to manage the operating system. It's a waste of resource, right? That's why the type 1 is based directly on top of the hardware with modified kernel. And type 2 is for tech enthusiast people like us who install the hypervisor like VirtualBox on top of our host operating system. Now, in case anyone has a query, then what is Vagrant here? The Vagrant that we have used is just a configuration file. VirtualBox will spin up the server for us. But the thing is, we're giving the configuration from Vagrant so that we don't have to go to the VirtualBox and keep doing next, 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 and keep on waiting forever, right? So we're just coming out of that part by using Vagrant. And plus, we also get more control by providing how much RAM, CPU we need, what is the IP address we need specifically. So all these things can easily be done with Vagrant file. So I hope at this point of time, we are clear with virtual machines, we are clear with hypervisor concepts, and a bit of Vagrant as well. Okay, I'm moving forward. Let's say everything was going good in life with virtual machines. So why did we even choose to go with container world or Docker, right? Let's talk about the problem with virtual machines. So these virtual machines are full operating systems. That means what is the minimum amount of RAM can you give or would you like to give to a virtual machine for a smooth functioning? Just don't say 512 MB. It will be good for testing, but it won't be smooth functioning. How much is the minimum you have to give? Minimum of 2 gigs of RAM and 2 cores we have to provide for the virtual machine or operating system itself. Now, there lies the problem, because we have to, even if we have a 64 gigs RAM system, that means at max we can spin up some 28 or 29 virtual machines max with 2 gigs of RAM, and they'll start having performance issues because they're supporting the full operating system. If someone starts consuming more resources, others will also start struggling. Now, these virtual machines are created with installing a complete operating system. So, since they're created by installing a complete operating system, we may not have a lot of CPU or RAM resources in the underlying hardware after installing or running a few virtual machines on our high-end servers. Okay? Yeah, and that is valid as well. That's okay. So these virtual machines typically tend to become very large, let's say hosting of a database on your virtual machines. And then if you try to migrate your virtual machines, it's again a big task, because the virtual machine images can be again in terms of GBs. So these were a few of the challenges in the virtual machine world, like performance issues and huge size, that prompted the containers to the rescue, right? In on a basic server, if I'm able to run 30 virtual machines, if I move to the container world, maybe in an optimized way, we can run 300 containers on the same machine, right? So that's why containers came to the rescue. So let's talk about containers and what they are. Just like the real world containers, analogical containers, this containerization is the approach in our software development where we package our software along with all its dependencies and configuration and ship it so that anyone who uses this package will get the entire configuration and dependencies already present there, and the application is bound to run. Let me rephrase it if it is not clear to you guys. Have you ever seen a scenario where people fight over the emails that this is not my issue, this is your issue, this works on the developer's laptop but it doesn't work on the tester's system, or it never works in the production system in one shot? Does it happens with you guys? Hello?
Yes, Deepak.
Yes, Deepak. Yeah,
Yeah.
sometime.
Yes, it's a very common phenomena because it is bound to run on the developer's laptop because he will configure his laptop to make it work anyways, right? And in case he misses some configuration or he misses to convey the testing team or the production team, operations team about some packages, then the software will not run on those testing setup or the production setup. So a better way would be to use a containerized application where all these things like configuration and dependencies are already pre-packaged in that container. Anybody who needs to run, they just need to run an image from that container and they are good to go. Like if you go back to the good old days when we used to have the Windows 98 or Windows 2000 or even Windows 10 disks, we just use that CD and install the operating systems on as much computers as we want. Forget the licensing for some time. So that means from a single image, we can install it on multiple systems, right? In the same way, from a single container image, we can run multiple containers. Okay. So from a single container image, we are running multiple containers. And these containers are already coming pre-packaged with its dependencies and configurations. So they're bound to run. Okay. So how these containers are deployed? These containers are deployed as a container image instance. Please remember, container images are always static. Images do not run. It is the instance of the image which runs as a container, okay? And they run on top of the host operating system. Now, every container can be your entire web application or it can be a service, okay? Like this. This can be an operating system on a virtual machine or a physical server, on top of which we have application 1, application 2, service 1 and service 2. All these things are running as part of the container, Docker container. So guys, let's make this session a bit more interactive. If something is not clear, feel free to let me know. I'm waiting here on this slide for the next 2 minutes for your questions. Okay, assuming there's no questions here. So now, if someone can ask me, nobody asked me actually, so what's the basic difference between containers and virtual machines? Okay. Now, before we go into deep dive into the containers versus virtual machines, let's talk about the similarities both containers and the virtual machines possesses. Now, these containers and virtual machines provide similar functionality, or they are similar in goals. Like they both isolate your application and dependencies into a self-contained unit. That's the same funda that virtual machine used to do. Every application has a separate environment because they are running on a separate virtual machines. Similarly, in the world of containerization, every application is running in a separate container. So that container is already having all its set of dependencies. So two applications are deployed on two different containers and they are isolated with each other. So both containers and virtual machines, they can run anywhere provided they have the bare minimum functionality or bare minimum dependencies provided. Containers need Docker to be present and running. If not Docker, then the respective container containerization platform like Docker is not the only container platform. There are other platforms like Arkit, Containerd, etc. So those things needs to be running. Containers and virtual machines remove the need for physical hardware for deploying your application. You don't need your physical hardware to deploy your applications just like the old days. You can deploy your application on top of the containers or on top of the virtual machines. Now, when you're deploying your applications on containers or virtual machines, that means using the same physical hardware, using the same CPU and RAM, and the same power, you are able to deploy multiple applications on the same physical hardware. That means it's a very efficient use of your computing resources like hardware, CPU, memory, storage, network, power consumption. At the end of the day, this is a very cost-effective model. Is there any doubt in the similarities between containers and virtual machines? Okay, so
Yeah, Deepak, so suppose I have multiple applications. So if you use the virtualization, a virtual machine means virtualization. So that time will come to the compatibility issue, correct? Suppose I
that time
have
will come to
compatibility issue, correct? Suppose one application I need some different version, another application I need some different version. So that time, if I use the same way, suppose mine one application Java 8, another application Java 11. So in the virtualization, that is not possible, correct?
no, Ramesh, it is possible. In that case, you will have a separate virtual machine for Java 8, a separate virtual machine for Java 11.
Yes, yes, that is correct. Yeah,
But
that is, yeah.
I'll just complete it. So, but both of these virtual machines will be on the same physical server. So,
Yes.
using the same amount of CPU, RAM, and memory or disk, or even say power, you are able to run two applications now on the same hardware. Correct?
Yes, yes.
That is why it is efficient. Okay. Any more questions from anyone else, guys? Please feel free.
Deepak, I have question here. I can understand that Vagrant file we are using the different IP to do our progress, but I just want to know what about why we uh, took this Docker in between. What it's actually do here?
Okay. Virtual machine, VirtualBox, and Vagrant are two different things. Okay. So, and Docker is a different thing. But what I did not understand is how does Vagrant has some relation with Docker? I'm not clear on that question.
No, I am just asking that if we are not considering Docker at this point, then why exactly we need it? Because we have the IP we can use that whatever concept you have explained right now. We can use all that right without having Docker, right? Why exactly we took Docker into picture?
Right. Okay. Right. Sometime back, that's what I explained, that containers tend to become heavyweight. Let's say on a physical hardware, you are able to run 30 virtual machines, okay, to host your application. So to host every virtual machine, the minimum RAM, according to me, we have to spend around 2 gigs, right? So we're wasting around 60 gigs of RAM for hosting those 30 virtual machines on that server. Is that clear with you, Anupam?
Yes,
Right.
yes.
Now, next point is if you replace those virtual machines with containers, Docker containers, so each container can take as low as 128 MB of RAM. At the high end, you can go up as much as your application needs, but the minimum barrier can even go less than 128 MB. Let's say 76 MB, 75 MB of RAM. Now you think, how much containers can you spin on the same physical hardware if you go with containerized applications? Get my point?
Okay, so you mean to say that with using the Docker, we can actually use a virtual box, something like that. We can
No,
you one go we can use separate containers at one go, like that.
no. Virtual machines are big brothers, heavyweight. Docker containers are small brothers, lightweight. Okay.
Okay, okay,
So let's say if you have a 10 gigs of RAM on top of which you can run, let's say 4 virtual machine. Okay. 2 GB for each virtual machine. Okay.
okay,
10 gig RAM, you are running 4 virtual machines. On the same 10 gigs RAM system, you can run 20 Docker containers.
okay,
Let's say 200 MB for every container. So maybe even more than 20 containers you can easily run on the same virtual machine, on the same physical machine or server.
okay.
Okay. So that is the thing. Containers do not require the same resources as virtual machines because containers are lightweight. Why containers are lightweight? I'm going to explain in the next slide.
Okay.
Is that clear with you?
Yes, yes, yes. Thanks,
Okay.
thanks.
Now, the difference between container and VM is their architecture approach, how they are. Now, you see, virtual machines, they use hardware virtualization. That means to run a virtual machine, you actually need to have a physical server below that. I can run a virtual machine on top of my laptop, or I can run a virtual machine on a server. But these containers are operating system level virtualization. That means my containers can run even on top of a physical server, or my containers can also run on top of a virtual machine. They do not need real hardware. They are virtualization at the OS level. That means they are just a process in the user space. Is that clear with everyone? It's very important.
Can you please repeat the last point which you said about container, this big difference in containers?
We didn't talk about that. We're just in the first 2 points right now. So the first 2 points are clear with you guys? Okay. Have you guys done a PS minus EF? What does it shows?
Processes which are running.
The processes, right? So to run the process, do you need a do you need a physical machine, or can those processes also run on top of a virtual machine?
Yes, it can run on top of virtual machine
Right?
also.
Exactly. That is what we say OS level virtualization. It's kind of a process that is running on top of OS for container. You don't need a physical machine. It can run on physical machines. It can also run on virtual machines. Both are fine. And so it's a process or OS level virtualization where the user space is used by for containers. Now, let me go a bit deep into containers. The containers have a private space. Why they need for private space? So that when you log into a container, you can execute commands in the container as root. Okay, it's just like a normal server. The containers also have a private IP address or a private network interface, so that communication can happen with to and fro from the containers. We can also set custom routes and IP table rules inside the container, just like the normal servers. And we can also mount file systems inside the container. Let's say we are hosting a database inside a container, we can mount file system so that one fine day, if I have to get rid of the container, my file system is still present. I'm just using another container, right? So my data does not get lost. Now, the big difference why the containers are lightweight than the virtual machines is because the containers use the same kernel of the underlying operating system, Linux kernel, okay? The same Linux kernel is used between all the containers on that host. But in terms of virtual machine, every virtual machine has their own kernel. They are complete operating system. Does this make sense? Hmm? Guys?
So yeah, hi Deepak. So I have one questions in that.
Yes.
Uh, yeah. So like see container images normally like we use for the applications one like so VM like you said images can be used for screen of the different operating system. So normally container images we are used for the application deployment or it can also screen the OS like different OS as well.
Okay. Yes. Container images are operating systems actually, Ritesh. Once we start doing the hands-on, I'll show you how they are operating systems, but why they are lightweight. But I'm pretty sure every one of you is aware that an operating system is running on top of a kernel, right?
Yeah.
So every virtual machine means every virtual machine has their own kernel, which makes them heavy and they require more computation. But when it comes to containers, they are definitely the same operating systems, but they don't have their own kernel. They use the host kernel. So the same host resources are required and it becomes faster and they are also lightweight. Now, one more thing. These operating systems inside the container are do not come with everything packaged. They do not have the utilities like you don't even have the ping utility installed on these containers. They are just lightweight because they are very much stripped down version of the operating system. Unwanted utilities which are not required are completely removed from the containers to make them lightweight. For example, a CentOS 7 image would be close to 900 MB or something like that. And the same CentOS container image is around 236 MB. So why is this space size less? Because the number of utilities is less in the container and kernel is also not present. That's why containers are lightweight. So please let me know if you have any questions here between containers and VMs. We can go ahead and answer them. Okay, let's say how this interaction happens. We know that containers are a process in the user space. So these process, what they make system calls which go to the kernel space and then they are able to access the RAM or the disk, okay, or CPU, something like that. And this is how the virtual machines look like: hardware, hypervisor, or standard host OS, on top of which we have the virtual machines, okay, with their guest OS. Now we can have our containers run here on top of these virtual machines. So all the containers running on this VM1 will use the same kernel of this VM1 guest OS. Containers running on VM2 will use the kernel of the guest OS VM2. Okay. Containers running on VM3 are going to use the kernel of this VM3. So that's all in the containers virtual machine section. Any more queries, please let me know. Okay, no questions. So then just talk about the things like containers. So we know that containers will package just the user space and they will not use the kernel or virtual hardware as packaging. If they have to communicate in the kernel space, they are going to use the system calls or syscalls.
Yeah, Deepak, so
Yes.
in the container, so can you tell the structure? So how in the base OS or host OS on top of the host OS, can you explain that particular?
Yes, it's there. It's there.
Okay.
Just hold on. So containers have their own isolated user space means anyone wants to guess what is the isolated user space? It means that if we have two containers and if I go ahead to container one and create a file inside that container, you cannot see the same file from container two. Okay, that means they have their own isolated user space. isolation. Now, OS level architecture is being shared across all the containers. That means the kernels is getting shared across all the containers. The only thing containers create for them is their respective binary and library folders or files. So this is how it looks like. You have the server, you have the host operating system. Okay. Let's say this can be Windows, CentOS 7 as well. That's how the traditional container works. Okay. This is your physical server. This is your host OS, can be a virtual machine. On top of which you install Docker engine, okay, or Docker. Just like to run Java applications, do we need JVM to run Java applications?
Yes.
Similarly, to run the Docker containers, we need the Docker engine to be running. So this Docker engine runs as a process on top of the host operating system, and then the containers run on top of the Docker engine. They just have the binary and the libraries, and then app is running on the containers. Any OS level thing, kernel, etc., is being used by the for the host OS. Okay, and the interaction between these containers and the host OS is being taken care by the Docker engine. Is this
Here, I have one doubt here. So container and Docker, what is the difference that one?
Okay. Containers is a generic term, okay, used for this process level virtualization. We call them containers. Docker is just one brand. There are other brands like Arkit, Containerd, which also allow us to create containers. Okay.
Means the Docker is the one tool, that one you can tell, or how will explain that one?
Yes, Docker is just a tool that creates container for us. We can use other tools as well, like Containerd, Arkit. There's something called LXC, which is termed as Linux containers.
Okay.
Okay.
Means container means that is the isolation process, correct?
Container means a virtual process in the user space.
Can you explain the user space in detail?
So user space is a Linux concept where the user is allowed to do things which does not necessarily has pseudo privileges, okay, or which does not has escalated privileges to directly communicate with the kernel or the hardware.
Okay.
Say you log into an operating system, whatever you do as that is a part of your user space.
Means that is the isolated. What I will do, we cannot see my things.
Right. Someone else is having a question. I can't hear you. Guys, can you guys please be on mute? Okay. If there's a question, please unmute yourself and let me know. Okay.
So Deepak, here host OS on top of the host OS Docker engine. There is no base OS, sorry, not base OS.
No,
So
I did not understood, Ramesh.
No, actually you mentioned here server, host OS and Docker engine. On top of the host OS, then we have to run the Docker engine, correct?
Yes,
Docker.
we have to install Docker and then it will run.
So there is no base OS?
No, not required in this case because we already have the server, right? So you log into any server in your office? Yes. When you log into this server, you are here after that on the host OS, generally RHEL or CentOS, right?
Hmm.
So this is that. Okay.
Okay.
Fine, guys. If this is clear, I'll move to the next slide. Now, we're going to talk about the Docker process flow. How does this process entirely happens? Okay. So this is the last theoretical section. After this, we're going to do the hands-on. Yeah, there are definitely 3-4 slides. So, how the Docker process flow happens is, in the very beginning, the developer is going to create his application, and then with respect to the application, he has to create a Docker file. Now, this Docker file is just like a bash script kind of thing. Syntax is a bit different, where the developer or the guy who is creating the Docker file will define how his application and its dependencies needs to be pushed into the Docker file. Okay, so he will define what packages needs to be installed, etc., etc. Now, once this Docker file is ready, using this Docker file, we're going to create a container image. And once this container image is ready, we are going to instantiate or run this image. How? When we run this service or by creating a container from this image, okay, that means we are instantiating the image. So image is static. The container is actually running. The container is an instance of an image or a running copy of the image. And this container is running on top of the Docker host or our server. Okay. Now, the image that we create as part of this Docker file will be stored in a registry, just like we store our code in a repository, GitHub or Bitbucket, right? Similarly, these images are stored in places called as registry. These registry are again public or private, just like our GitHub or Bitbucket are public and private. Okay, so we have this registry now. Now, in this registry, we can store the applications or the images which are called as immutable application bits. Okay, in this registry, we can store our Docker images. Okay, these Docker images are static and immutable application bits. Now, let's say you created an image today, again we create an image tomorrow, and then day after tomorrow. How do we differentiate between all these 3 images created in all the 3 days? Simple. We can version these images. Okay. So images can be versioned, add version to this image, and based on the requirement, we can deploy these into different environments. Okay. Please go through this slide once and let me know if there is any query or doubt in the process flow. Okay, if there's no questions, then we move to the next slide. Now, previous slide we talked about the Docker file. Let's see how does the Docker file looks like. We don't want to understand everything right now. I'm just giving a brief overview at a high level. We're going to go in depth of all these things. Now, Docker file, as I explained earlier, is kind of a script, just for understanding. In actually, it's a set of instructions how the Docker image should be built. Let's say our Docker image should have something installed. So we'll use like this run apt-get -y install some package. These run or expose or env, the first ones, are called as directives. They have certain special meanings in Docker. We're going to go through them eventually at some later point of the time and explain you, right? So run means these things will get executed inside the image. Expose, that means these ports will be exposed to the world. can be accessed later. Environment means set the ant home to some path, key value pair kind of thing in the Docker image. Similarly, this is one more example of a Docker image. We may not need to understand everything right now, just an example, okay? So the first thing is to create a Docker file, we have to start from some base package, right? So let's say we did from Golang. Golang is the image name. This is the version 192-Alpine 3.6. As build is a keyword we used here. Now we're doing something run apk add, you know, cache git, you're doing some apk addition, then run go get github.com. Whatever we write after run will directly get executed inside the container. Okay. Then copy, that means copy the file go pkg.log from the local system inside the container into the path go src project. So we're copying this go pkg.log and go pkg.toml inside the go src project folder in the container. Now, in case this go src project folder is not present in the container, Docker will create it automatically. Work dir go src project means it's as good as cd go src project, like cd to this directory. Then again run directive, with this part dep2 only will get executed as it is. Copy, it says dot, then there's a space and then there's a path. That means copy whatever is in the current working directory to this folder go src project inside the image. So and so it goes on. There are different directives like from, run, copy, work dir. More we are going to talk eventually. We're going to repeat them all once again. So are we good with a Docker file, how it looks like? We're not worried about whether you understand everything right now or not.
Deepak means Docker file means that is the set of instruction we have to define.
Yes, to create your image or package your application and its dependencies, right?
Yes, yes.
We'll
Means my application needs some software, so I need to define that the prerequisite.
Correct.
This is my software, Linux, this one. This is the Alpine, this is the OS. I need to select the OS. I need to install some Java. What are the prerequisite required? So step by step, I need to write in the Docker file, correct?
Yes, yes. The dependencies, correct.
Yeah, hi Deepak. I have one question.
Yes, hi.
Yeah, so we are writing the Docker file, right?
Yes.
So from the Docker file, we need to define all the things where we need to took from the base image.
Correct.
So how to create the base image? That is the main important, right? From the Golang 1.9.2 is the base image. So for all the mentioned commands taken from this base image, right? So how to create the base image first?
Whenever you do an application thing, right? Build an application, you first try it on your system, correct?
Okay.
Then you are already aware about whether the base image is going to be based out of CentOS or Ubuntu or Alpine. You're already aware of that part for your application. And then based on that, you're going to search in the Docker Hub repository if that base image is there or not with respect to that operating system, and then you pick it up, use from CentOS or from Ubuntu, etc.
Okay. Okay.
Yeah, Deepak, according to our project requirements, so we need to define that base OS.
Right.
Suppose sometimes in the Docker Hub that base OS is not available. So what will happen? It will take some default or how will happen?
Okay. There are times that you actually need a completely entire new base image which is not present in Docker Hub. In that case, you can use you definitely will have a tar of your operating system or something like that, a stripped down version of that tar, and create a base image out of it that is completely from the ground zero.
Okay.
So there's a process. I can share the link with you guys, but it's not a thing that we discuss as part of our standard um, trainings.
No, no, yeah, understood. So you have to do the tar and get that one.
Yes,
So
yes.
when you mention from, it will only fetch into the Docker hub. So how will it fetch into the local?
How?
Will fetch into the actually in the tar widget. So we need to push into the Docker hub. We have to
Obviously,
create that.
you have to push
Okay.
it to Docker Hub or your organization's repository.
Okay. And there itself, if you push that one, when you mention from image, so is there any credential we need to mention how will fetch that one?
Yeah, yes, obviously, if there's any credentials, you have to do a Docker login, and then only you'll be able to fetch it.
But in the Docker file, if you mention that one from that particular way, so automatically will take. Or is it required to provide any credential in the Docker file?
See, it depends. It depends completely because your images can be stored in public registry and private registry.
Yes, yes.
If it is in public, you don't have to use any credentials, but if it is private, you will have to use credentials.
Okay, okay.
Okay. Any more questions, guys? Okay. I'm going to another Docker file. Just have a look at this Docker file, see how it looks like, and if you have any questions, please let me know.
Um, Deepak, I have one question.
Yes.
Yeah, so here it is defined entry point, and in the next line you have defined command. So I have seen Docker files where the command and entry point, oh, just one of them is required. So what's the difference between these two commands?
Okay, we have it. We'll talk it later when we go over
Mm-hmm.
the Docker file. But yes,
Mm-hmm.
both can run.
Okay.
Okay, any more questions? Okay, if there's no more questions, I'll move to the next slide. I'll just talk about the Docker engine. You see, how does Docker works? When we go ahead and install Docker on our system, there are three components that get installed: the Docker engine, the Docker client. The third component is kind of an abstraction or what? It's kind of REST API. So what happens? Docker engine is the core, or it's a layer where Docker is actually running. It's responsible for all the Docker functionalities. Docker functionalities like managing your containers, image, the builds, how it is happening, managing the volumes, networking, etc. Anything and everything that Docker does is part of your Docker engine functionality. Right? And this Docker engine runs natively on Linux system. It does not run on Mac OS or Windows. Now, you may say that yes, you have run it on Mac or Windows, but that's how Docker works. Is it creates a separate virtual machine isolated from us, and when you do or execute some Docker commands, it's actually doing a REST API call to your Docker engine on Windows and Mac. Okay. So the Docker daemon is running on the host computer. Your Docker client communicates with the Docker daemon, and this communication is happening entirely on the REST API for interacting with the Docker daemon. Now, please remember that does not mean you install your Docker daemon on some machine and your Docker client is on some machine. Things can be done, but that's not recommended because Docker daemon and client, they generally communicate over the same loopback IP address. Otherwise, people tend to lose the track where the Docker is running, which Docker client is pointing to which Docker engine. We don't want to land into that scenario. Okay? So the key takeaway is there are three things: the Docker engine, the Docker client, and the REST API. Docker engine, or we can also say Docker daemon, is the core. A Docker client is a place where, say, let's say when we do a Docker PS, so we are actually interacting with the Docker client, which will form the REST API call of Docker PS and send it to the Docker daemon or the Docker engine, which will parse the request and then respond back with a response. Okay. So Docker client is the guy that we're using as the end user to talk it. Like, let's say when we are doing Docker build something, we're just passing these things from Docker client, and it is a Docker engine or the Docker daemon, which will where the actual thing is going to be done, and it will respond back to us. Okay. So any questions with respect to the Docker components?
Yeah, Deepak, can you tell the detailed structure that when suppose as you mentioned Docker PS, so when someone will Docker client will mention Docker PS, so how internally communication happening?
Ramesh, I think that is beyond the scope of our discussion.
Okay.
But when we talk about Kubernetes, I can show you those things, how to do it in a verbose way. Then you can go through those things.
Okay.
Now, we have registry here. This registry is again a Docker component, which we have already discussed. Its primary responsibility is to store the Docker images. Okay, management means the versioning of the Docker images, or when we do a Docker pull or something, then in that case, delivery of the Docker images based on the authentication and authorization if required. So this registry can obviously be of multiple types, like it can be Docker Hub registry, which is the by default registry, or it can be a private registry, or it can be some different vendors. There are different types of Docker registries available. Okay, and you can version your images, etc. Now, one thing that we talked about, the difference between images and containers. Anyone who remembers? Can we change any image?
No, it's static.
Images are static, and containers are the instances of those images. Now, since images are static, so whenever you deploy that container, the base image is the same for everywhere. So you always get a consistency. So no one can say that it works here, it does not work on some other operating systems. Now, there are, again, terms and conditions, again, here also applies. The moment we start going to Kubernetes and looking into different concepts like config map and secrets, we'll see there's a bit of tweaking as well. But let's wait for that. Now, let's say when we start creating containers, how does it happen from the base image? Let's say the base image is Debian and images are static. So how do we add the Emacs, or how do we install Apache in the image? Anyone who has already worked? Okay, let's say this is a base image which is based out of Debian. Now, how do we build a Docker image? Anyone?
The Docker file.
Base image.
The Docker file we have to mention.
Docker build.
Docker build -p. Then
right. So what happens when we do a Docker build and pass the Docker file argument to that? So what happens on top of the base image, whatever it is, you'll see a lot of SHA checksums getting printed on the console. If you've done it earlier. So what happens from the base image, a new container gets instantiated only during Docker build. Okay, and then the next layer it says add Emacs. So Emacs is added on that container, and then the container gets committed. So when you commit a container, you get a new image. Now this image is having Debian as the base image plus Emacs is there. Now in the next layer, we are saying add Apache or install Apache. So how it will happen? Images are static. So from this image, again a new container will start. Docker will start the container. It will execute these instructions, add Apache or install Apache, and once this instruction gets completed, it will commit the container. The containers we can modify, right? Images we can't modify. So when the container gets committed, we get a new image. And maybe this is the final image that gets shipped to us. And now, once we run this image using Docker run, we are getting a final container that is writable. Please remember, there's a difference between Docker run and Docker build. Docker build is to create the base image using multiple layers of containers, which Docker will create and demolish all by itself. But when we do a Docker run, that means we are actually instantiating the container, instantiating the image for our application. Okay. So is this process clear with everyone, how these containers are getting created layer upon layer? Is there any questions?
So Deepak, it is like one thread created to create Emacs and Apache, and it is getting automatically closed that thread, something like that.
Kind of automatically. So the Debian base image from this, a container will run. Now the container is running means the container is writable, modifiable. So we can add this, execute this instruction in the container. Once this execution of the instruction is done, the container will get committed. This will be automatically done by Docker. So when you commit a container, you again get a new image. So this is a new layer. Now, in the next, it says add Apache as the instruction, but you can't modify an image. So what happens? Docker will again instantiate this image, and a new container will come, which can be modified. So these instructions are executed on the container again. Once the execution of this instruction is done, the container is committed again, and we get a new layer image.
But even though new image will be created, the old image what we have created earlier, that will persist, right?
Those will be discarded. Intermediate layers will be discarded.
Oh, okay, thanks.
Okay.
So Deepak, once one container is writable, after that, if I want to add any software, so how that would be possible?
After that you want to add
Any software like?
Yes, no problem. Now this is writable container. Let's say you instantiate this image and your containers is running. This is for you. It is running. Okay. So you just log into container and install something and do a commit. You'll get a new image. I will show you that as well. No worries on that part. In the hands-on, we will do that. Okay. So once again, guys, let me show you this. All these run things, whatever is happening with this run, are a part of this intermediate layer. Whenever a run is there, it is executed only during the image build time. Okay, Docker build. So now I'm moving to the next slide, guys. I think we had enough of theoretical discussion. Now, if you ever want to go drill deep and explore, there's some Docker community Slack. You can go to the Slack link. You want to follow the Docker events, you can go to events.docker.com and you can follow the Docker events happening around you across the globe. So that marks the end of the Docker theoretical section. Next, we're going to start with Docker installation and do some hands-on. So before that, before we start these things, let's go for a break and come back in 10 minutes is fine for us, right? Well, let's come back by 10:30. So we'll start sharply at 10:30. So please be on time. And Hey guys, hope everyone is back by now. Hello, guys. Am I audible to you guys?
Yes, Deepak.
Yeah, yeah.
Okay.
Yes.
Okay. Thanks. So guys, can you see my terminal?
Yes.
Awesome. So what I'm going to do is I've sent a set of commands to you guys to install Docker. So what I'll need you guys to do is just execute it as it is. Become root user on your Vagrant machines. Okay, execute it. Let it happen. While at the back end, I explain you the meaning of those commands. Is that fine for everyone?
Yes, yes, Deepak.
So I just did the same. You can also try the same. Okay. So should I go ahead with the explanation of what we're doing? Okay, I'll just explain you what we're trying to do with Docker installation. We're installing Docker on CentOS 7. There are multiple ways. I chose the repository manager way, where we install the required packages first. So yum install -y yum utils, all the yum utilities, then device mapper persistent data. This is for mapping the persistent device, and LVM to logical volume manager too. Internally, Docker will use all these utilities somehow. Okay. Now, after this is done, so that means the dependencies for Docker is completed. Okay. Next, what we're trying to do is we're trying to set up the stable repository information into Yum so that it is able to fetch Docker. Okay. So what we do, Yum config manager add repository, and this is the Docker repository. Okay. Download.docker.com Linux CentOS Docker -c dot repo. CE means community edition. After that, when you do a sudo yum install docker -c -y, that goes ahead and installs Docker for us. Okay. And once that is done, do verify your systemctl status Docker. It shows whether your Docker is running or not. If not running, you can go ahead and start your Docker. Okay. Now, please remember for executing your commands as for Docker, please make yourself as a root user using sudo su. In your organization, you may be using some other user, but yes, to use Docker, you need to have some elevated privileges. We don't want to go into the complexity of creating users, giving permissions, so we use it simply by creating a root, by logging to the root user. Okay, so be a root user and then start Docker if it is not running. Enable Docker if it is not already enabled. Okay. Start Docker means it will start the Docker daemon or Docker service. Enable Docker means it will ensure that Docker service goes into the auto restart mode. That means after the server reboots, you don't need to manually restart Docker. You just need to, you don't need to do it. The system will automatically start the Docker. Okay, it's like Windows startup programs. So please do it. Okay, I think my system has got a bit of issues, so I'll just take care of that first.
Deepak, can you share all the commands? So mine disconnected.
I've already shared the commands on the chat.
So after Vagrant app, means we have to go into the virtual box, and then we have to execute this command.
Right, guys. I'm expecting that you're executing all the commands inside the Vagrant virtual machines.
That cube M one.
Yes, QBAM. Perfectly fine.
Deepak, in my machine, Vagrant has not been installed, and I don't know, I'm facing some issues. So after this training, can we connect and see what's the issue?
Mm, you can drop me an email right now as well with the screenshot of your issue.
Okay, it just said that the Vagrant is command is not recognized. Even if I've installed and the Vagrant file, everything is done,
Just terminate
still.
your command line and open it once again. It will recognize.
I did it, but I've even restarted the system, still not having it.
Let's see.
You're expecting me to share the screen?
Yes.
Yeah, sure.
You guys are not sharing the screen right now. You can execute those commands, everyone. Okay.
See.
Okay. And Vagrant is installed.
Yes. Shall I show you on the control panel?
Yes. Have you tried reinstalling
Yes, did it twice.
reinstalling Vagrant?
Yes, I just uninstalled it, then again reinstalled it, still facing the same thing.
Okay. This is a 16 gig system, right?
Yes.
Um, Apart from Vagrant, have you ever launched any virtual machines on your system?
Mm, Virtual machines, no, the
Okay.
first time.
Fine. Give me 5 to 10 minutes. I'll share some link with you. Okay.
Yeah, sure.
Skip the Vagrant part for you.
Hmm. Okay.
I'll take the sharing back again.
Okay, I'll stop share then.
So guys, is Vagrant installed? Sorry, is Docker installed for everyone?
I think this is Anupam. Actually, I shared you the screenshot today morning, right? So I am getting similar thing while running these commands.
Um, just give me one moment, please. Just one moment. Yes, Anupam, you can share your screen, please. Let's see. Others, I'm working on the assumption that Docker for you has been installed and it is running perfectly fine. Anupam, can you please share your screen?
Yes, yes, sure, sure. One moment.
Yeah, Anupam, you have not logged into the machine, right?
Yes, yes, I am already logged in. Yes.
No, no, you're not. You're inside your PowerShell only. Just do a vagrant SSH space SSH
Yes, yes.
SSH space QM. Please open your VirtualBox once.
Yes, Deepak, please.
So there's no server running for you. You've already logged into QM, right?
Yes, it's already logged
You're
in.
using Hyper-V.
Yes, yes. Actually, I messaged you right that.
Right. Yes, now I remember. Okay, I'm not much aware about Hyper-V, but I think you're able to log in. Okay, can you do an IP space A? Okay, you are here. Mm, what is your IP? I can't read it properly. It's zero. It's 172. Anyways, so you can execute your commands for now. This will be fine. Become root user sudo su. But going forward after the session, I need you to disable your Hyper-V and use the.
Actually, if I am disabling, I am unable to use the commands. Vagrant up and all commands not working. It is asking to enable that. That's why I thought personally I enabled
I
that.
would say check with some of your colleagues who have done it already. Okay, if
Okay.
they're not able to help you out, then let's connect in the evening.
Okay. Okay. Sure.
Okay,
Sure. Sure.
I'll
Okay.
take the sharing back again.
Yeah. Sure.
Am I audible?
Yes, you're audible. Tell me.
Yeah. I am also facing some issue when I am running Vagrant SSH QBM command. Can I share my screen?
Guys, let's not take any more issues with respect to the environment. Um,
Okay, then shall we connect in the evening for the same?
I'll say first connect with your colleagues and get this sorted. If it's not able to get sorted, then let's connect. Okay.
Okay, Deepak.
So guys, please cooperate everyone because there's a lot of participants and I cannot help everyone for the sake of time. Okay. So just please support here. So at this moment, guys, we have installed Docker. Okay. On my system also, I've also installed Docker. Let's say, and my version is 2010.8. Okay. Now, I get this error, cannot connect to Docker daemon. Is the Docker daemon running? Because my systemctl status of Docker says that it is inactive or dead. So what I need to do is, I just need to start it up. So now once I start the Docker and check the status, it is running now. Okay. So I'm assuming the Docker is running for everyone as well. I'll also enable my Docker. Systemctl enable Docker. So now the Docker service has been enabled as well for me. Now, what we do once we install a new programming language, the first thing we do is we try the hello world, right? Similarly, for Docker, the hello world is to run the hello world image or the hello world container. Okay, so what I'll do is Docker run hello underscore world. Guys, let's first see what I'm doing and then you can try. I'll give you 5 minutes for that. Okay, have a look into my command Docker run hello world, and when I press enter, the first thing it says is it's unable to find the image locally. What does this mean? It just means that this hello underscore world colon latest image it is not able to find on the local system where Docker is installed. So it tries to pull it from the repository. But from the public repository also it gets an error response from daemon, full access denied for hello underscore world. So it's not able to figure out the hello underscore world because full access is denied. Either the repository does not exist or it is a private repository requiring Docker login, right? So either it's a private repository or actually the repository does not exist, and that's why denied request access to the resources denied. So if you have a look closely, I did a typo here. Instead of hello dash world, I did a hello underscore world, and then I can just keep on googling around. I won't be ever able to figure out what happened. So the point is, if you give the wrong image name, you may get access denied, but the problem is the repository may also not be actually the repository does not exist as well. Okay? So now when I made a correction, I am doing Docker run hello world. Now let's see what happens. It tries to figure out hello dash world. Exactly, that's what the image name I gave. But then why did the latest come? What is latest here? Anyone?
It's the tag for the image.
Right. Latest is the default tag. If you do not specify any tag explicitly, the tag is specified after a colon, then latest would be the default tag. Now, it doesn't find this image locally, so it tries to pull from library slash hello world. But wait, we never gave this library. So what is this library now? Anyone?
It's present in the Docker Hub
Yes,
repository.
absolutely. But what is it? Okay, anyone who remembers the format of a Docker image, how it is?
From run copy.
Okay, this is the standard syntax or the complete Docker image syntax. So first is your Docker repository URL, then is the username, then is the image name, then after colon is the tag. So now what is library here? Come on guys, I gave you the answer.
Image name. Right?
It's the username. Okay, fine. So before the image name, whatever it is always a username. But then what is the repository URL then by default?
We already, I think, gave.
I'm sorry.
Dockerhub.com.
No, the repository name is docker.io.
Okay.
Anyways, the idea behind this is when you try to use your private images, you see there is a big something something dell.com initially. Anyone remembers? And then you have some username and then the image name and then your tags v1, v2, v3, latest, whatever it is. That is the complete syntax of your image name. Let me know if there is even the slightest doubt in this. Please note it down. Now that is fine. Now let's see. It's trying to pull the image. Now pull complete. This is the SHA checksum, SHA 256 digest. Okay, B8D somewhere you'll find this, whatever it is, and then the image gets downloaded, and the image is named as hello world, and the tag is latest. And when the image ran, that means the container ran, it printed something this much. And after the print happens, what happens to the container? Come on, guys, you guys have worked with Docker. What happens if I print this much? I'm sorry, this is wrong. Echo. What happens in this echo hello world?
We'll print whatever the double quotes
And
inside.
then what happens to the echo hello world process after printing? What does this gives anyone?
It
Dollar
will give you the existing status of the command.
last command, right? It's zero. So what does zero means? It's a
Success.
graceful exit. That means success. Yes, correct. So I'm printing something with echo hello world. It is printing. So that means to print, a process gets spawned or a process gets forked. And once the string is printed, the process exits gracefully. That's why echo dollar is zero. Okay. Now, the same thing happened when this container ran. The container was supposed to print this message only. And after printing this message, the scope or the job of the container was completed. So the container will terminate. Okay, that is what I wanted to infer. So let's say Docker images. I hope you know this already. Docker ps, Docker ps minus a. Now you see, Docker images gives you the list of the images. That is okay. I didn't download RabbitMQ. Maybe my image that I'm using for this virtual machine has all these things by default. Anyways, the repository name was hello world. The tag was latest. The image ID is this, which is always unique. It will be the same for you guys as well. This hello world image was created some 6 months ago, and the size of this hello world image is 13.3 kilobyte. Any doubts or questions here? Now, when I do a Docker PS, I do not get any output. Why?
Because there is no running containers in our
Absolutely.
VM.
When we do a Docker PS is supposed to show only the running containers. Okay. Now, if you say why the hello world container is not running, no, that is the discussion agenda. We are up for it. When I do a Docker PS minus A, it shows me all the containers running, stopped, terminated, exited, everything. So it shows the container ID, which is unique across this Docker instance only. The image, image name is hello world. What command got executed inside this container? That is /hello. It was created 5 minutes ago. Status of the container has exited. What is the exit status? 0. And you guys told me 0 is a graceful exit. Ports, let's not talk about this right now. The names for this container is dreamy Mr. Man something something. So the thing is, these names for the containers will always be unique. If you don't specify any custom name, Docker will assign one for us, and that would be unique across. So one final time, any questions with Docker images or Docker PS or Docker PS minus A? Please let me know now. Okay, now let's move to the next agenda. Why did this container hello world exit? And even if it exited, why it exit status is 0? Anyone can help explain us? Come on, guys. We just saw an example with this. Anyone? Anupam, Biswajit, Raghav. Okay, let's see. This command hello was just supposed to print certain things. Okay, it the container started, it printed hello from Docker. This message shows that your installation works correctly, etc., etc. And then after this gets printed, the container's task or the task was done. So it will exit out, and it definitely exited, and it exited gracefully because that was the only thing the container was supposed to do. This container was not meant to run forever. Okay, so how do we make a container run forever?
F1D detach mode or something option.
No, it won't help. The thing is, everything is here in this command. Is this command a blocking one or a non-blocking one? Let's say, for example, has everybody done a basic hello world on Python, Python app.py hello world? Or everyone has run a basic web application?
Yes, yes.
Everyone.
Yes, yeah.
I'm assuming that. If someone is not, you should let me know. So when you do that, let's say Python app.py, the app runs forever unless there is an error in the code, right? And whenever you visit the website or the browser, do a refresh, the logs keep getting populated. Why is it so? Because it's a blocking command, right? It doesn't end now, but these commands, they end. They print something and they have to exit out. So it all depends on the command, that is the CMD that you have mentioned in your Docker file, or the entry point that you have mentioned in the Docker file. That defines for how much time the container is going to run, whether it's going to run forever or it's going to run momentarily. Okay, I'll give you 5 minutes to try this demo on your system. Finally, I just ran this command, right? Docker run hello world. I ran this command. You can try the same on your system and then try other things. Docker images, Docker ps -a. Have a look at this exit status and come up with questions if you have some. Okay. So right now it's 10:58. I'll wait till 11:05. Please do complete the demo on your side.
Hi, Deepak.
Hey, hi.
Can you paste the commands you have run in the chat for the Hello World?
It's highlighted on the screen. No? Are you guys?
Before that, the first ones.
The first one was a wrong command actually. I wrote it this one.
Okay, okay, okay.
For explanation. Okay.
Yeah.
Instead of this dash, you can use underscore if you want to replicate.
Okay, okay. Thanks.
So Deepak, like, so where we can see like Docker file here?
I'm sorry, you can't see the Docker file from the image. Okay.
Okay.
You can't see that. Okay, guys, do you have any questions, queries, doubts? Nothing.
Deepak, I'm getting permission denied. So, what was the command you have done when you got permission denied?
I
Sudo.
think you need to run with like
Sudo,
sudo.
sudo, sudo, sudo.
Okay.
Do not wait for me. If you have any questions, queries, something is not working, let me know at the same time. Okay. Um, guys, if this is done, I think I'll talk about an important aspect. Let's say sometimes not the latest version may not be the right fit for you for Docker, right? So what you can do is you can do a yum list docker dash cp show duplicates and sort in a reverse order, something like this. Yum list docker dash cp show duplicates sort minus r. So that lists you all the different Docker versions available today as of now, and you can install something of your choice. How do you do that? Do not install, okay? By the way, yum install minus y docker dash c dash. Okay. Let's say we are just using this, right? 186cc3. So what I'll do is, yeah, we don't see that right now, so I'll just use this one. Use it like this one, and we're good. Okay, we can install. The idea is to, if you have some very specific Docker version to be installed, go with this way. Now, next I'm going to again reiterate the Docker images, how they are being built. And then after that, we're going to talk about some Docker image searching, etc. Now, we talked about Docker images that they are static files, static application bits. They are also termed as read-only templates, right? So the foundation for Docker images are a very much simplified version of the Linux operating system, which is very much stripped down version of an operating system. Stripped down means with just bare necessities of binaries and libraries. So let's say this is a stripped down version. Now you're changing this foundation by installing different applications and dependencies in every layer. Okay. And finally, you arrive at a layer called as Java 6. This is your image. And then you broadcast to your organization that anyone who wants to use Java 6 can use this Java 6 image of our organization. Now, what is the benefit of this? First thing is this image gets private to your organization. You can put up your security patches. Not all Docker images or every Docker image available publicly has got a lot of vulnerabilities. So that means when you're importing those public images, you're also importing those vulnerabilities absolutely free of cost. You don't need them, right? So your IT team or DevOps team or DevSecOps or InfoSec, whoever is there to take care of the security, they will take that public image and patch it up with different layers and install your dependencies and give you a Java 6 image, which is completely patched. It can also have your DNS entries or something, or org level things. And then the different teams can use this Java 6 for hosting their my app or my other app or XYZ app. They can use the same base image, right? Now these images, Docker images are built using Docker build command. We all have discussed this, not officially, but yes, theoretically, verbally. We'll see that later as well. Now we know these Docker images are built in layers. So if you see the Docker file, every line in Docker file will add to a new layer. So there are optimization techniques in Docker images called as resource chaining that will talk eventually once we become a bit more fluent with Docker images and layers. Now every layer is a file system and it is combined in a UFS or union file system, that is a single image. And they are the build component and they start from a scratch base image. Okay, scratch may be a wrong term, base image is fine. Now we can also create custom base images, and we know that Docker images are built by just adding more layers. So that's just again a brief overview of Docker images. Now the question comes, I'm going to start my development over Docker. Now, which image should I use? Right? That is the big challenge. Docker has a huge number of base images in Docker Hub. Right? There are multiple Linux distributions. Now, which am I going to use? The first thing that we have to do is use the Docker search utility. Search for Java, lot of images. Search for anything under the sun that you want to search. Let's say Oracle. Okay, you'll get lots of options. I'll explain you how to interpret these options eventually. One more search. Let's say I want to search for Zabbix. Zabbix is a monitoring system. So again, I have few more images for Zabbix. Now let's come to our actual example. Docker search CentOS. Now you see, when I do a Docker search CentOS, it gives me a lot of images. First is the name, then the description, the stars. These are the ratings or rankings. Official, automated. Official means whether it's the official package or not. Automated means whether it is deployed, the image is rolled over or deployed via CI/CD pipelines or not. Okay. Now let's talk about the CentOS. Now, what is this CentOS? Is this an image name or a username?
Image name. Image name.
This image and this image. This image has this. What is this?
Username. Username.
Username.
And this is the image name.
Image name.
But why is there no username for CentOS? Now let's see one more thing. What was the username in case of Hello World? Anyone remembered?
Library.
Library.
Library, right? Now, if you see something here, it says official OK.
So it means like,
is it like that the official images have a username called library? Let's verify with CentOS.
yes,
This also does not has a username and it is also official.
it is under like library.
Absolutely. So all the official images have library. So for official images, it is docker.io/library/CentOS:latest. Okay. This would be the entire string for that image. Please remember, by default, when you do Docker search, it is pointing to Docker Hub only, and you can't change it to your own custom repository. This is for ambiguity resolution. However, in Red Hat Linux, there's some switch or parameter. I don't work with RHEL. I'm limited to CentOS 7, so I don't remember the switch name. Using that, you can change it, but that is only for RHEL. It is not present in any other operating system. Okay, so if you have to use your own repository name, you have to give your repository name, username, and image name completely. Otherwise, by default, it will always point to docker.io. Is that clear with everyone?
Yeah.
Fine. Have a look at this highlighted text things and see if you understand each and every bits and pieces. If there's any doubt, just let me know. I'll wait 2 minutes only.
What does this stars means? This 6747 over here.
Those are the ratings, rankings. This much people have liked it.
Okay.
So it's like trustworthiness.
Okay. And when we'll say CentOS, that is name, and when we'll say CentOS 7 Ansible, that is what you said is the image name.
This is the
No,
image
no,
name.
something else. Image name.
Yeah, and this is the username. Let's say
Yeah.
you go ahead and create your own user in Docker Hub. Okay.
Okay.
So let's see. Let me see if I can search anything for my username. Yes, I have so many. So you see, hello DK is my Docker Hub username. Okay. And then this is my image name, SparkPy or Test App, Quad, AMD64, To Do, Part Server, lots of things. Right?
Okay.
So none of them are stars. That's okay.
Since those are personal.
I don't use them and I don't publish them for so much users. That's okay. So I hope this is good with everyone. And you all also understand what is this automated okay?
It's for CI/CD pipeline, right?
Right. Like it's just like when you push a code to GitHub or Bitbucket, your application gets deployed to staging or production, right? Automatically. Similarly, when you push your Docker file to GitHub or Bitbucket, the image automatically gets built and published to the repository. That means automated. Cool guys, I think this is good enough for every one of us. So in this section, we talked about how to do Docker search facility, how to use it. Very simple. Now, we also know how to use Docker images. Um, and how do I remove a Docker images? So please remember, RMI means remove image. Docker RMI RabbitMQ. Okay. Anyways, this RabbitMQ is not my image. Now, this is correct. I'm trying to remove an image, but this image has a reference to this container, which is already in stop state. So you can't remove the image like this. You have to use force. Now, when you do a force, your image gets removed. So hello world is removed.
Deepak, what is the use of this force? Docker RMA hello world.
You see, we try to remove this hello world. Okay.
Okay.
But this hello world image cannot be removed because it has a reference to this container. You remember there was a hello world container ran and then it got exited. Now since that container exited, but still that container is using a reference to this image. Okay, hello world, this image. So to remove this, you have to use ---- force. Is that clear? Hello.
Yes.
Yes.
Okay. Fine. That was pretty simple thing. So let's not go into that part. Now let's start something interesting. Now, how do I execute some commands on the containers without even getting logged into the container? Okay. So let's say Docker run CentOS hostname. Now, please remember, this is a very important command. When I do a Docker run, that means the container is getting instantiated for the first time. It's never the second time. You don't start any containers using run. It is the first time. That means instantiate a container with the image name as CentOS and execute the command hostname on top of that container. Okay. Now, the question goes to every one of you. When I write CentOS, that means what is the image name that will be actually being used? What is the username here?
A library.
Library.
And what is the tag?
Latest.
Latest.
And what is the repository URL?
Docker.io.
Okay, cool. So we all are clear? Anyone having slightest doubt here? Awesome. Now run this. This was bound to happen because this image is not there locally. So it is downloading. As you guys said, library is the username. It is downloading from there. Now these are the different layers, SHA checksum layers. Okay, the size of the layers is 75.18 MB, and this much has been downloaded. Let it complete, and then a few more layers will get downloaded eventually, if any. So it downloaded and it gave the see, container ID is this 2500F. Image name was CentOS. The command we executed was host name 9 seconds ago. Exit status is 0, and the name was wizardly direct. That means the container definitely ran, it gave the output, printed the output, and then exited gracefully. Are we good with that?
Yes.
Yes, Deepak.
Any questions?
Sorry, Deepak, what is this host name? It is the default keyword or something?
Oh, no. We gave the command here, no? That to be executed on this container.
So can we give any other command apart from host name there?
Yes, we'll give that, but sometime later.
Okay.
Let's repeat this once again. Will the image get downloaded this time? No.
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 So it printed a different host name. Let's try once again. What is this happening here? Anyone can explain? Why do we have different host names here? We're running the same
Each time
command.
it initiate the new container.
Yes, new instance actually.
Absolutely. Every time we do a Docker run, a new instance gets created, right? This is the container ID, which is actually the host name by default, unless you explicitly specify that. So these commands were getting executed on the container. They gave the output, and they all have exit status as 0. And you see their names. They are unique. Now, let's try to do one more thing. What if I want to name them according to my choice? So what should I do? Name C1. Okay. So this is just the container name. It's not the host name. I forgot the parameter. I think it's minus host name something, but that's not important actually. Now you see we run another container with this name C1, and now you see this name has been C1. So that means using this name parameter, we can control the container name. Okay. Please remember.
Yes.
Yeah, one thing you should take care that this name parameter cannot be after CentOS. Okay, because Docker expects the second last argument to be your image name. Okay, so that's why it will fail. Your image name should be in the second last or in the last options. But
Deepak, sorry to interrupt. What was the command for that -a? What it will do? Second last, which you have run.
this one,
Yes.
this prints all the containers running or stopped state, all the containers.
Okay, kind of ls for this.
Ls, no.
Okay.
It just prints all the containers which are in stopped, running, terminated, exited state.
Okay, fine. Thank
I
you.
can't find an analogy right now. Okay.
Okay.
Guys, why did this fail? Can someone help me out?
Maybe runs first command is argument is name.
Yes, this name already exists in the.
Absolutely. You please remember these container ID and container names are always unique. You can refer a container by their names or the container ID. So they need to be unique. So you can't run the same container name once again. If I do a C2, it is fine now. If I try to do a C2 again, it's an error because the name is already in use. Even though the container is in exited state, that's okay.
But you have mentioned in C2, right? C1 is already present, but C2 is not present, right? So why it is failing?
This time it passed, here it passed one time. Second time when I try it again, then it failed.
Okay. Okay.
Valid, right?
Yeah.
Okay, I hope this is good enough for us. Now, one more thing. You see, these containers are exited and are of no good use now. We can't start them back again.
That was straight interrupting. So one more thing, after you ran this Docker run hyphen name C1 CentOS host, and after that one also you told we need to run as like Docker run CentOS hyphen name C1 host, right? What is the difference between those two commands?
One is wrong, second one is right. When I use like this, okay, it fails. And starting container process exec minus name is not found. It takes this as an argument image and tries to execute this command on top of this image.
Okay.
So put all these things before the image name.
Okay.
That just comes with practice. Or maybe I never found any documentation that explains this.
Okay.
Well, anyways, once you're done with this, there's a problem. You see, these containers are exited. Okay, this is in stale state now. Okay. The point is, what if I want to remove these containers? Okay, so what I'll do is docker rm c1, docker rm c2. That will remove the container. Please remember, rm is remove container, rmi is removing the images. Now c1, c2 are gone. And now if I want to remove all the containers, so how should I do that?
Rm star will work,
right? No. You see, there's a command called docker ps minus aq. So what does it gives all these things?
Container ID.
What if I do docker rm
Image ID.
container id?
Yeah, correct.
Okay, I'll just pass this docker ps minus aq. Now what happens? Docker rm, you know what does docker rm does? Removes the container. And when you pass an argument like this, which will iterate over all the containers and give their IDs. So what happens essentially, you're passing all these IDs to docker rm. And you see, now if I do a docker ps or docker ps minus a, nothing is there because all these things have been removed as part of this argument. Okay. So the key takeaway from this is docker run CentOS name C1 this command and docker ps minus aq. Please get yourself familiarized with these 4 commands. I think they are pretty simple. 2 minutes should be okay. Repetition may not be possible, so please get it done this time itself. If you have any questions, let me know.
Deepak, would you mind just explaining only that AQ, PS minus AQ is there, right? What exactly does the Q do here?
It filters out the container ID. Okay.
Okay.
For me,
So it does. Does that mean that only the stopped containers or all the containers that appears?
All the containers.
All the containers. Okay. Thank you.
Okay, are we done with this? Anyone pending? No one, right? Fine, guys. I'd like to talk about one more example in the same context. Let's say when I do a Docker run CentOS C1, C2. Now you see these containers definitely get exited, but the point is their entries are still there in Docker PS -a. What if I don't want to have these entries? Essentially, that is important so that I can reuse the names. So there's one better way is to, let's say, Docker run -rm. Let's make them C3. So what does rm does is it, as the moment the container exits, it's also removed from the Docker records. So you see only C1 and C2 are there, C3 is not there, using the --rm flag. Okay, so it's a standard practice that we do to ensure that the containers entries are not present here if you have to reuse the names. Is that clear with everyone, or someone wants me to re-explain? Hello. Hello.
Yeah, yeah, it's
Yeah, yeah.
No question, guys?
Yes, I have question that why we want to do like that, creating and deleting in a single step. It's never.
The point is, Anupam, let's say I don't use this, okay? Um, the point is, if I just want to print the host name, that's it. Now every time I try to do this, I have to change the name again and again. But the moment I use RM, I can use a command multiple times. So the point is, the container definitely did its job and it exited, right? What's the point to have exit container here? You can't even start these containers because their life cycle is done. They have exited,
Okay. Okay.
right?
Got it. Got it.
So better remove them if they are done.
So can we rename like a container name?
No, no, that's not done. That's not required.
Okay.
Okay, so I'll just delete all the containers. Done. Now someone was asking, what if I want to run some other commands, right? Perfectly fine. Instead of host name, let's print date. Date will anyways keep changing, right? You can print pwd. You can also print cat of etc.conf. Okay, yeah, it's not going to take this. This will be too much. C3 centers.
Host we can see, correct?
No. Let's try it out. But ideally, we don't use it like this, right? HSTS. Yeah, no, we can't see that. I can do ls, etc. But that's okay. The point is change the argument and check your data. That's it. It's not rocket science. Docker images, Docker RMI, we have already seen. And now let's talk about how do we add custom packages. Someone was asking, right? How do I install packages into my container? So now we are going to land up into the container and try to add some packages to that. Everyone is ready? So to land up into the container, first of all, the container needs to be running, right? So there's no container running for me, so I'll just make one. Docker run minus IT. This is important. Minus minus RM. I'll do. Okay. Minus minus name C1. CentOS. That's it. So when I do like this, what is this minus minus name CentOS?
That image ID.
This is the name.
Container name. Okay.
Yes.
Container name will come first and the image name will be later. Then CentOS colon latest. I will not write latest because it will pick up by default. Okay. I did Docker run minus minus RM. Everyone knows minus minus name. Everyone knows C1 is the container name. CentOS is the image name. IT is the new guy here. I means interactive. Let's try with I. Do not try with T. Okay. It will be a bit ls. Okay. pwd. I have landed into the container actually. Okay. Now I can do an exit. Now you see, as long as I was in the container, did you find anything peculiar while I was executing the command? Let's try this way. The same thing, this time I use T. What is the difference do you see between running with only I and running with T?
It will give user name.
It gives you a kind of a terminal prompt. Yeah, terminal, you can say that. I is interactive and definitely it was. When I gave ls, it gave me the output. When I gave pwd, it gives me the output. That is interactive. But you also need the terminal to understand what is happening around. So root @ hostname. Okay. That's why we use IT together. Please do not use T alone, because you'll only get the terminal and it won't be interactive. Then you'll have to open another terminal altogether. So that's why I'm not showing you that example. It's bad actually. So anyways, you'll always have to use it as IT. I for interactive, T for terminal. And you see now I'm inside the container. The container is actually running at this point of time. Anyone like to say why it is running? Because I've demanded that I want a session inside that container, right? So the container will wait until I do all my commands. The moment I do an exit, the container is gone. Okay. So let's go again and try to install something. Is this funda clear with everyone?
Yes, Nikhil.
Anyone who is having the slightest doubt, please feel free to let me know. We can get this clarified.
When
Cool.
you say exit, it will come out of that container, right?
Absolutely. Let's say if this is my terminal, right? The moment I do an exit, that terminal got away, right? Same thing happens with exit. It just comes out of this terminal. And the point is, the moment you come out of this container, the moment you come out, there's nothing that the container should wait now. So container's job is over. So the container will also exit gracefully.
Okay.
Okay. So no when you do a docker ps -a, the container will not be running. Now, I'm inside the container using this command. I want to install something. Let's say yum, let's say telnet. Telnet google.com 80. It says telnet not found. So what I'll do is install -y telnet. So I'm installing telnet here. Please see first what it is doing. It is first updating the cache, yum cache, and then it is installing telnet. And once telnet is installed, this works fine. Okay. Have a look again what I did. Using this command, I landed up into the container and then I tried telnet, which did not work because telnet was not there. So I went ahead and installed telnet, yum install -y telnet, which updated the yum repository, and then it started working fine. Then I tried telnet and it ran fine. So I need you to try this demo on your system, understand it. Also, please be informed, I just installed a basic telnet package. Okay. You may install as many number of packages you want. That's absolutely your choice. I would not suggest it right now because we have one more example where we are actually going to create a custom image. Okay. Please do try it. It's 11:43. I'll wait till 11:46 for you to complete this demo and ask questions. So guys, anyone who is still pending to complete this demo? Everyone is clear? Okay, cool. So let's exit out of it and the container will stop. Now, there's something called as inspect. Okay. What this inspect does, it inspects the Docker image and returns back certain parameters. Like say, we'll not go into the complex mechanisms. I'll just show you some basic things. Like Docker inspect CentOS. So what it does, the CentOS image, it will inspect and it will tell you the different parameters of this image, like what is the SHA checksum, repo tags, CentOS latest, the digest, when was it created, okay, not on our system, but when was the image actually created, what are the containers, okay, so what were the host names, um, what is the Docker version, and other things like architecture, operating system where it's being used, what is the size and virtual size, etc. Let's say out of these things you just want to extract a specific piece of information, then just use this architecture and give the image name, okay, centers, okay. uh, Sorry, I should not have written it twice.
Deepak, can you also put the commands which you type in the chat also? Because sometimes I miss that command.
This one?
Yeah, this whatever you can you do would be helpful.
One-liners are difficult, but so you can try these things. These are simple things. Done, everyone?
Deepak, one small question.
Yes, yes.
Is there any specific reason why we have to use two brackets?
That's the way the syntax is.
Okay, so instead of architecture, if I want anything else, also the syntax is still remain the same, right?
That's how it is. Yes, yes.
Okay, thank you.
If you're aware about JQ tool, you can use that as well. I'm not much aware about JQ, but I know using that also we can do filtering. So guys, it's already 11:50 at this point of time. We have talked about Docker image and logging to the container we've already seen, so we'll not repeat it again. What I'm going to do is I'm going to talk about the container creation flow, and then we'll close it for today at this point. And tomorrow, once we come back, we'll talk about working with containers and take it forward about other things like how to start, stop container, list the Docker stats. Deleting containers we've already seen, but we're going to talk about how to run a container forever, right? Which containers run forever, like Nginx containers. And then we're trying to build custom Docker images, so on. A lot of interesting things to be done tomorrow. So let's talk about the container creation flow. So you see, this is how it works. This is a private network. This is your home Wi-Fi, okay, where you have your laptops. Okay. Or yeah, this is the best example. This is your laptop. On your laptop, you have installed, or this is your virtual machine, background virtual machine, where you have installed your Docker Now, Docker has its Docker client and daemon. In the Docker client, you do a Docker run CentOS hostname. So this Docker client will do an HTTP request REST API call to the Docker daemon. Docker daemon will parse it and figure out the CentOS, and then it will go to the Docker hub, download the repository over HTTP from the public internet. Okay. Or if it's a private uh, Docker registry, it goes to the private Docker registry. Or if it is another public Docker registry, it goes to this registry and it pulls the image anyways. Once the image is pulled and the requested task is completed, it responds back on the standard output to the Docker client. Okay, that's how the entire flow is working. So if you have any questions till this point and whatever we have spoken, please feel free to let me know. No questions, no queries? Okay. Guys, I wanted to ask how many of you have issues with the virtual machines as of now? Arshita and hello. Fine. If no one is having issues with the labs, then that's cool enough. We'll close for today then. And again, please be on time tomorrow.
I think I have some issues with the in the chat. I think like if you are having issues with.
Yeah, even I have it. No,
In chat, we have pinged Deepak.
Okay. Yeah. Jyotsana, Chetna, George, Yashwini, Ravindra, Mitra, Induvani. Okay. You all have issues with respect to the labs?
Yes, for me, Vagrant Up is giving some error.
I'm sorry?
For me, Vagrant Up is giving the error where it is not able to download base something from the remote directory.
Okay. Can you